In this video, I want to look at the proof that the sum of the first n positive integers turns out to be n times n plus 1 over 2. For those of you who are math majors, you will see this proof again in a discrete mathematics course. That's our Math 270. But the proof technique in that course will probably be mathematical induction. What I want to do here is a much more straightforward proof, but it does require some cleverness. The first thing that I want to do is I just want to look at what this sum is. So if I look at this sum as k goes from 1 to n of k, what I've got is 1 plus 2 plus 3 plus, and it keeps going, and I want to write more than just the very last term. I'm going to say that I eventually get to n minus 2, and then I eventually get to n minus 1, and then of course the sum ends at n. And the reason I want to do this is I want to focus in on looking at pairs. So if you look at the pairs of numbers that I am putting together with these arrows, you'll notice that they all add together to be n plus 1. 1 plus n is n plus 1, 2 plus n minus 1 is n plus 1, 3 plus n minus 2 is n plus 1. So we can keep doing this, but it's not completely clear what happens to the middle. So somewhere these n plus 1s wind up ending at the middle, and the question is what's going on at the middle. And so the middle is a little bit more difficult to deal with. So what I want to do at this point is I want to think about the following things. I'm expecting the answer to involve an n plus 1 times something, and I just don't know what the something is. So something. And what I want to do is I want to try and be even more clever and look at the sum written in two different ways. So first of all, I'm going to let S be my sum, and I can of course rewrite this sum as 1 plus 2 plus 3 plus, and again I'm going to write several ending terms. And now what I'm going to do is I'm going to turn this around. My sum is clearly going to be n plus n minus 1 plus n minus 2 plus all the way down to plus 3 plus 2 plus 1. And now what I'm going to do is I'm going to try and rewrite this sum where this is k is equal to 1. So what I'm going to do is I'm going to be thinking about this. This is n plus 1 minus a 1. And now this term here can be written as n plus 1 minus a 2. And the next term, this term here can be written as n plus 1 minus a 3. And we keep going, and we're subtracting an additional thing off of n plus 1 each time. And when we finally get down to this term here, this 3, that can be written as n plus 1 minus, and I'm going to have n minus 2. And my second to last term, that 2 is going to be able to be written as n plus 1 minus n minus 1. And my last term, of course, that 1 up here is going to be written as n plus 1 minus n. And actually I picked the wrong color there, so let me clean up my notation. And the reason I've done this in the colors that I've chosen is that I can see that my sum can now be written as a summation as k goes from 1 to n of n plus 1 minus the k value. All I did was turn the sum around, but when I look at it cleverly, I get that the sum can also be written this way. So this sum and this sum, and that is an awful summation sign, so let me clean up my notation. These two sums are actually the same thing. Now, what does that mean? That means that I can add s plus s together and get 2s, and what I'll have is this summation plus this summation. Now, because the counters are both going from the same k goes from 1 to n to k goes of a term, I can put these two things together and we get the following thing. We have 2s is equal to the summation as k goes from 1 to n of k plus n plus 1 minus k. But if I think about what's in here, k plus n plus 1 minus k is nothing more than n plus 1. And so what we've now got is 2s is equal to the sum as k goes from 1 to n of the constant n plus 1. And so this is just going to be n times n plus 1. Well, if I think about that, that says 2s is equal to n times n plus 1, divide both sides by 2, and we get s is equal to n times n plus 1 over 2. And so that says that the summation as k goes from 1 to n of k, which was equal to s, really is n times n plus 1 over 2. And so we've got our formula proved.